Okay, let's work our way through these questions. You should be marking these from your own work as you go along. So it says, what is the speed of a water wave? So we're looking for V of frequency 4 hertz and a wavelength of 3 centimeters. We're going to use V equals F lambda. If this was a GCSE exam, I'd be looking here to see, does it give me a unit? It doesn't. So I could work in centimeters. So I would get 4 times 3, which is equal to 12, but that would be centimeters per second. Or I could do the conversion, which would be divide by 100 to change that into meters. This is probably the better way of doing it, to be honest. V equals 4 times 0.03, which gives me a velocity of 0.12 meters per second. However, it's not specified, so any of those should get the full marks. What is the wavelength? So we're trying to find lambda of a sound of frequency 264 hertz if its speed is 330 meters per second. V equals F lambda. V equals 264. Sorry, we're given V, so let's put that in 330 times lambda. Divide both sides by the 264, and typing that into your calculator should give you 1.25. This is in meters per second, so this will be meters. Question 3, find the frequency of radio waves of wavelength 1,500 meters if their speed, and this is the speed of light, is 300 megameters per second, or 300 million meters per second. Now you can write that, and your calculator might come up with this as 10 to the 8 meters per second, just means 3 times 10, 8 times. But we can write it out in full. So V equals F lambda 300 million equals 1,500 F divide 300 million by 1,500, divide both sides really by 1,500, and that will give us a frequency of 200,000 hertz. Okay, last one is more complicated because there's a lot of information here to deal with, and actually a lot of questions being asked as well. In an exam, I'd be tempted to draw a diagram here. So let's draw a little diagram over at the side. So it says the horizontal distance between the first and fifth wave crest. So let's draw 5 waves. Okay, so that's 1, 2, 3, 4, 5. So there's our first, there's our fifth. It tells us that that distance from there all the way to there is 40 centimeters. It also tells us that the distance from peak to trough is 24 centimeters, and it also tells us then that we get 30 waves, or 30 oscillations, or 30 vibrations in, what is it, in a minute? So in 60 seconds. Now, what I can then do is we want to find the number of waves in 1 second to find the frequency. So divide that by 60, divide that by 60, and it gives me 0.5 waves in 1 second. So that tells us F is 0.5 hertz, and that's asked here. The amplitude, now if we look at our little diagram here, the amplitude is the maximum displacement from the mean position. So what we mean by that is these particles in the wave would usually be here. If there's no wave present, they will move up to here. That's the maximum positive displacement. They might move down to here. So we can also give that as an amplitude. So the amplitude is not 24, it's going to be half that value. 24 divided by 2 is 12 centimeters. Wavelength then, be very careful with this. How many wavelengths is there between here and here? It's not 5, because if we count them, let's see, I'll just use green again. Between there and there is 1, there and there is 2, peak to peak 3, another peak to peak 4. So we really have 4 wavelengths there. And 4 wavelengths are 40 centimeters long, therefore one wavelength will be 10 centimeters long. Once we've got that, and we should probably convert that to 0.1 of a meter, we can then work out the speed, because we can do v equals f lambda v equals 0.5 times 0.1, so v equals 0.05 meters per second. Now you may have stuck with centimeters, which is okay because it's not specified, and I'll give you 5 centimeters per second.